Hello and welcome to Unit 5, Lesson 3, Graphing Square Root Functions. In this lesson, we will be graphing square root functions using Desmos, and we're going to translate those graphs of square root functions. Key vocabulary that we need to know is square root function, and then we also have to recall our definitions of domain, range, and parent graph. So let's take a look at what a square root function is. A square root function is a function that contains a square root with the independent variable in the radicand, remembering that the radicand is the expression under the radical sign. The parent square root function is f of x is equal to the square root of x. So we remember from parabolas and quadratic functions that there is a parent function that is the most basic form of the function. And so here you see the parent function of a radical function, square root function. And on the left, you see the table of values. We're plugging in 1, 4, and 9 for our x value. And we can see what our function equals. So if we take the square root of 1, we get 1 back. If we take the square root of 4, so we're plugging 4 in here, so square root of 4 is 2, so that's our y value. And if we take the square root of 9, we can plug that in, 9 in for x, and we get 3 back. And now we have some ordered pairs, 1, 1, 4, 2, and 9, 3. And when we graph those, they are not a straight line. They make a curve, and this curve resembles kind of a sideways parabola. Because square root and quadratic are inverse operations, you see this shape. Notice that we don't have the bottom of this shape because of not being able to take a square root of a negative number. So right now we only see the top of the shape, and as we explore, we'll see how we can get the bottom of that shape to see that full parabola. So when we talk about any function, we have to start by talking about the domain of the function. So the domain is the set of all x values that make the function true. And we can find this domain two ways. So we can find this domain by looking at our graph. So I have the smaller version of the graph here, and our function is still the parent function. So our domain says how wide the graph is. So we're going to start here. And how wide does it go? Well, this graph goes on forever and ever. So we say that x is greater than or equal to 0, 0 being where our graph starts, and it goes up or gets larger, and that graph will never stop, so it's every number bigger than 0. If we don't have the graph, we can also find the domain algebraically, and we can do this by setting the radicand, or the expression under the radical, greater than equal to 0. So we would say x in this case, because x is under the radical, is greater than or equal to 0. If we have more expressions here, we would go ahead and solve that, but right now we just have x, so we are done. So our domain is x is greater than or equal to 0. So now that we've looked at the domain of the function, let's take a look at the range. So the range of the function is all of our y values. So with the range being all of our y values, we are going to look at how tall the graph is. So we're going to start down here, and we are going to see how far this graph goes up. And in this case, our graph will raise to forever and ever. It just continues getting wider and wider. So we say that y is greater than or equal to 0, similar to our x value. Now, algebraically, this looks a little different. So when we look for the range, I want to look at what number over here is added or subtracted to my radical. And in this case, it is 0. And then I have to look at the sign in front of the radical. And in this case, it's positive. So if it's positive, then we say that y is greater than or equal to 0. If the radical would be negative, we'd flip this sign. So let's take a look at some more examples. So let's find the domain and range of each of these square root functions, and we are going to do it algebraically and then look at it graphically to make sure we are on the right track. So domain, in order to find the domain, I am going to take the expression under the radical, and I'm going to say that 2x plus 1 is greater than or equal to 0. And we can remember that we always have to use greater than or equal to 0 because we know that the number under the radical has to be positive. And so in this case, we're going to solve for x. So I'm going to subtract 1 from both sides. So I get 2x is greater than or equal to negative 1. Then I'm going to divide both sides by 2. So x is greater than or equal to negative 1/2. So my domain says that my graph is going to start at x is negative 1/2, and it's going to get bigger. So it's going to go to the left. And now we want to look at range. So there's two things we look for range. So range, we look for the number that is added or subtracted to the radical, and we look for the sign. It's positive, so when it's positive, we say that y is greater than or equal to negative 5. Now let's take a look at the graph of this function to see if we did it correctly. So we're going to flip over to Desmos, and in Desmos, there are two ways to make the square root function. You can press the keyboard down here and get the square root or the radical there, or if you type the letters SQRT, it makes a square root for you. So we have 2x plus 1, and then outside the radical minus 5. So I'm going to close this here. So we can see, if we look at the graph, make this a little bigger so we can see that a little better, that my graph does start at x is negative 1/2, and it gets bigger, so x is greater than negative 1/2, and we see that y starts at negative 5, so my range is y is greater than or equal to negative 5. Let's flip back over and look at our other example. So in this example, we're going to do domain. And to find the domain, I'm going to look at what's under the radical. So x minus 1, and I'm going to set that greater than or equal to 0. I'm going to add 1 to both sides. So our domain is x is greater than or equal to 1. And then our range is the number outside here. So range. So I'm going to write the 4. And then I'm going to look at this sign here, and that says if it's negative, then y is less than or equal to 4. And let's go ahead and graph that one real quick to make sure that we did it correctly. So if we go here, we're going to say y is negative x minus 1 plus 4. Plus 4, and I'm going to set this home, and we see that in this case that my x value is 1, so y is, and it's getting larger positively, so x is greater than or equal to 1. Now my y value is at 4, which is what we said, and this graph has kind of flipped. It is the bottom half, so we say that my range is y is less than or equal to 4. Let's go ahead and explore those graphs a little more. So once we know how to find the domain and the range, we need to look at how a graph moves on the coordinate plane. And we call this the shifts of the graph. How does the graph shift from the parent graph to its new location? So if we're looking here, we see the parent graph. And in our examples, the parent graph is always going to be the red graph. So we say, let's take a look. When I have the equation or the function f of x equals 3 times the square root of x, we see that our blue graph, it's a stretch. So we call this a stretch graph. And we can see that it's getting larger by quite a bit because it's outside of that radical. So it is stretching larger. Now let's take a look at the next type that we can possibly come across. So our next graph is f of x is the square root of 3 times x. So now the 3 is inside the radical. And we see that again, it's a stretch. It's larger than this graph. So this is another example of stretch. And it is larger, but it is less than this stretch up here. So if the stretch is inside, it's a little less. Now we have a negative outside of the square root. And when we see that this happens, this is called a reflection. So that graph is reflected over the x-axis or the domain value there. And you can see now a little more clearly that full parabola. So if you have a positive square root and a negative square root, you can make that full parabola. So this is a reflection. Now we look at the graphs where x is added something to it and the inside or subtracted something to it. So we can see again our red graph is our parent graph. So when I add something to it on the inside, to the x variable on the inside of the radical, my graph shifts left. So this is a left shift. And so we usually say it moves kind of in the opposite direction. So plus 2 under the radical really moves left 2. And so likewise, if I have minus 5, I'm going to move in a positive direction. So it kind of moves opposite. So minus 5 moves right 5. So we call this a right shift. And this can be a horizontal shift. Left shift, horizontal shift, right shift is also horizontal. And the last two we're going to look at give us that vertical shift. Okay, so when that x, that plus or minus is on the outside of the radical, so plus 1 is going to move up one direction. And the negative 3 is going to move down. So there is no stretch. It just moves or shifts on the graph. So these are vertical shifts. So vertical positive shift and vertical negative shift. Okay, so now we look at these two graphs and we try to remember our shifts. We have to look at all of our parts. So the first thing is this is going to be a stretch because there's a 2 attached to the x. This number tells us our horizontal shift, so we're going to move left. And this here tells us our vertical shift, so we're going to move up.